Hi students, welcome to this class. So in the previous class I have explained the various forms of continuity and we discussed some problems on continuity. Okay, so in this video I am going to explain the discontinuity and its type. So in various cases the function will be discontinuous. Discontinuous means what? So it is not continuous. For example, let us take a graph. So x-axis and y-axis. If there is any function, it is a somewhat break is there at x is equal to a. Then we say that the function is discontinuous at x is equal to a. That means it is has a break. Okay, now then in which cases the function is discontinuous? Then how to say the function is discontinuous at x is equal to a? So before saying that, let us see the when it is continuous, when the function is continuous. Let us see this. So first a function or curve, we can call it as simply a curve, f from R to R is said to be continuous. Said to be continuous at x is equal to a. Said to be continuous, not discontinuous. Continuous at x is equal to a if and only if the first condition limit extends to a, f of x is equal to f of a. Limit extends to a, if one and only one condition, the limit extends to a, f of x is equal to f of a, then we say that the function is, the curve is continuous at x is equal to a. Let us see when the function is discontinuous. When the function is discontinuous means, what is the meaning of this? So this is the meaning of this means limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a. In which of the following cases? So now I am going to write down some following cases in that the function is discontinuous. Okay, na? The function is discontinuous. The first case is limit extends to a minus f of x, limit extends to a plus f of x does not exist. Any one of the does not only no need to both any one of limit extends to a f of x, limit extends to f of x does not exist. That means left hand side limit, right hand side limit, any one of the left hand side, right hand side limit does not exist. Then the limit extends to a f of x does not exist, therefore it is not a continuous. Second case is if limit extends to a f of x, limit extends to a plus f of x exist, both exist and they are not equal. They are not equal. Both exist, but they are not equal. And that time also the function is discontinuous at the point x is equal to a. And the third case is limit extends to a f of x, limit extends to a plus f of x exist and exist, the both are exist and equal and both are exist and both are equal. That means what? Limit extends to a f of x is exist, but they are not equal to f of x. They are not equal to f of a. That means limit extends to a f of x not equal to f of a. At that situation also the function is discontinuous at x is equal to a. Now coming to fourth one, f of a is not defined. F of a is not defined. If f of a is not defined, that means if you don't know the functional value of f of x, if it is x is equal to a, so here it will come f of a. So if you don't know the value of f of a, if it is not defined, then only we say that the function is discontinuous at x is equal to a. Okay, now so to check the continuity of the function, so if you do the three things, it is enough. Find the left hand side limit and right hand side limit and find the f of a value. Three values you find out. If all these three values are equal, then we declare that the function is continuous at x is equal to a. If any one of these following cases arises, if any one of the following cases applies, that means both does any one of the one is does not exist. If both exist but they are not equal, if both exist and both are equal but they are not equal to f of a, understand? So if both exist and both are equal and limit extends to f of x is also exist, it is there, but the function is not defined at f of a, and both exist and if it is not equal to f of a, so in various cases we say that the function is discontinuous. Okay, now in continuous there are no types are there, okay, only continuous, but in discontinuous there are different types of discontinuities is there. So let us check that different types of discontinuity. Okay, welcome to this concept. So already we have seen the continuity of a function, and we have discussed the various cases where the function is discontinuous at a point. Okay, right. Now in the discontinuity we have various types of discontinuity. One is a removable discontinuity and another one is non-removable discontinuity. That means what? We can remove the discontinuity. For example, let us see the one diagram. So this is a x-axis, y-axis. So there is a function, it is there. There is a function. Here left hand side limit is there. Left hand side limit at x is equal to a. LHL is equal to RHL. LHL is equal to RHL. Both are equal. Limit extends to a. F of x exists. But f of a, it is not defined. F of a, it is not defined. So if you define, for example, if x is equal to 2, x is equal to 2, for x is equal to 2, some f of x is equal to 5. So if you define that, then it will be closed. That is removable. That is a removable. That means we can remove the discontinuity. Okay, na? So we can, by definitions or by taking some substitutions or taking some assumptions, we can fill that gap. We can fill that gap and we can fill that bridge. Okay, now. But there are some discontinuities is there. It is a non-removable. We cannot remove that discontinuity. We cannot make it continuity. So in this removable, that is a removable which we can add the removable. There are two types are there. One is a missing point discontinuity. Another one is isolated point discontinuity. This means these two cases we can remove the discontinuity. Coming to non-removable, that is impossible to remove the discontinuity. That means we cannot make them close. We cannot make them close. So that means all chances are there. Okay. So we cannot connect them, those two curves. So that is called non-removable. In this there are three cases are there. One is a finite type non-removable discontinuity. Another one is infinite type non-removable discontinuity. And the third one is oscillatory type functions are there. So in that also, if there any breakage is there, so we cannot connect them and we cannot continue them. Okay, now by any means we cannot continue. So it is a non-removable and it is removable. So I will make you understand by taking a small examples. Okay, now. So I hope that you understand this concept. So let us move that. One by one I will explain these cases. Okay, now. So let us continue our concept. Hi students, welcome to this concept. So one by one I am explaining this. So missing point discontinuity. So this is a removable. That means we can remove this discontinuity. So let us take one example. So very easy example I will explain. Let us take a function f of x is defined at x square minus 1 by x plus x minus 1. X square minus 1 by x minus 1 when x is not equal to 1. Okay, if you take x is equal to 1, you will get an indeterminate form. So this is a function. So let us observe the graph of this function. Okay now. So if it is f of x is equal to x square minus 1 by x minus 1, we know that x square minus 1 x plus 1 into x minus 1. Since x is not equal to 1, we can remove x minus 1 we can cancel. So this is x plus 1. Okay now. Let us try to draw the graph of this function. So this is a x-axis and it is a y-axis and it is origin. So let us take this as a 1, 2, 3, 4 and it is a minus 1 and it is a minus 2, minus 3. 1, 2, 3, 4, 5 like this. Okay now. So if x is equal to 0, y is equal to 1, 0 comma 1. Okay now. And if it is a y is equal to 0, x is equal to minus 1. So this is a minus 1. So the graph is like this. Okay now. So at x is equal to 1, the x is equal to 1, it is not defined. X is equal to 1, the graph is not defined. So I will remove this so that it will be very clear. Okay now. The graph is not defined at x is equal to 1. F of 1 is not defined. F of 1 is not defined. That's why it is discontinuous at x is equal to 1. It is discontinuous at x is equal to 1. But after redefining this function, so redefine the function, then we can make the function, make the curve, make the straight line as a continuous. How? So let us see here. This is a 1. Now I am defining this function like this. F of x is a function such that x square minus 1 by x minus 1 when x is not equal to 1 and 2 when x is equal to 1. X is equal to 1, 1 plus 1, how much? 2. When x is equal to 1, so I have defined that when x is equal to 1, f of x is equal to how much? 2. That means if x is equal to 1, the function f of 1 value is equal to how much? That means we fill that gap. So we filled that gap. So instead of defining this function like this, if you define the function like this, that means what? Missing point. One point is missed. So you define that point. One point is missed here. What is that point? X is equal to 1. At x is equal to 1, you define f of 1 is equal to 2. Therefore, the gap will be filled. The gap will be filled. So here left hand side, right hand side, both limits are equal. Okay. Therefore, the gap also will fill. Then you will get a straight line. This is called missing point discontinuity, which is removable. We can remove this discontinuity. Okay now. So that means we can make them continuous by defining the function like that. Okay now. So here it is not given x is not equal to 1. If x is equal to 1, what is this? 2. If you define that, we can remove this discontinuity. Okay now. So I hope that you understand this concept. Let us see another type of discontinuity which is removable. Welcome to this isolated point discontinuity. Isolated point discontinuity which is removable. Okay now. So let us see that signum function. So the signum function is defined as if x less than 0 in the domain for all negative values of x, the function is defined as 1. For x greater than 0, for positive values of x also, the function is its a functional value is 1, image is 1. But at x is equal to 0, it is 0. So if you observe, if you draw the graph of this function like this, so let us draw the graph of this. This is a x-axis and it is y-axis. Here x-axis and y-axis is there, and it is a 0 and it is a 1 and it is a 1. See here, for x less than 0, f of x is defined as equal to how much? 1. That means we can take another pen. So this is up to here. Okay now. For x greater than 0, the function is defined as also 1. So here. But there is a gap is there, but that gap, so unless the previous example, there the graph at x is equal to 1, the function is not defined. But the function is defined at x is equal to 0, it is 0. It is 0. Understand this? It is 0. So if you observe here, limit extends to 0, f of x is exist. limit extends to left hand side limit is 1, right, at x is equal to 0, left hand side limit is equal to 1, right hand side limit is also 1. So limit extends to 0, f of x is equal to x is, that is equal to 1. But it is not equal to limit extends to 0, f of x is not equal to f of 0. Why? Because if f of 0 is equal to how much? 0. So this point is called isolated point. So that is only the point which is away from the main graph. So x is equal to 0 is the only point that is away from the graph. Only point that is away from the graph. Then how to define this function to make it into the continuity. So how to make it into continuity? Okay, now so let us define this function like this. So this is equal to signum function f of x is equal to, otherwise f of x is equal to, so modulus of signum function x if x is not equal to 0, 1 if x is equal to 0. So if you define x is equal to 0, if x is equal to 0, if x is equal to 0, it is value is 1. Therefore, this now this whatever may be this now comes here. Now the graph will be continuous. Okay, now so if signum function is defined as a modulus of s, that means what you will get for left hand side of x and right hand side x of x, you will get a modulus of this signum function. And if x is equal to 0, if x is equal to 0, it is defined as 1. Okay, now right. So then the function will be defined and that isolated point discontinuity will be removable. Okay. So I hope that you understand this concept. Let us move to next type. Welcome to the remaining two types here. So non-removable discontinuity, that means we cannot remove the discontinuity. Okay, na? By any means, by defining anything we cannot remove. For example, see in that the first type is finite type, another one is infinite type, asymptote type we also call. Let us take one example. F of x, the function is defined as when x less than minus 1, the function is defined as minus x plus 2. When x greater than or equal to minus 1, the function is defined as x square. The function is defined as x square. So let us draw the diagram so that we can understand this easily. Okay, now right. So let us take this as a x-axis and it is, and y-axis. This is 0, 1, 2, 3, 4. So this is a minus 1, minus 2, minus 3, minus 4 like this. So for x greater than or equal to minus 1. So minus 1 and more than minus 1. If it is a minus 1, so here 1, 2, 3, 4, 5. So if it is a minus 1, image is 1. If it is 0, 0. If it is a 1, 2, 4 like this. So this is y is equal to x square. Y is equal to x square. Understand this. Now coming to this, this is a parabola, but here from minus 1 and greater than or equal to minus 1. That means right side. So the graph is like this. And coming to y is equal to minus x plus 2 when x less than minus 1. So let us take x is equal to 0. If you take x is equal to 0, y value is equal to how much? 2. So y value, if x is equal to 0, y value is 2. So this is equal to 0 comma 2 we will get here. 0 comma 2 we will get. Okay, na 0 comma 2. So another one, if y is equal to 0, minus x plus 2. So therefore x is equal to 2. So therefore this is a 2 comma 0. So where is so x, if it is y is equal to 0, this is equal to minus x, sorry, we have to take this not y value. So let us take for minus 2. If it is x is equal to minus 2, so we will get here x value, take minus 2, minus of minus 2, 2 plus 2, 4. So you will get here something point. So if you draw the like this, the graph will be. So definitely clearly there is a gap between these two functions. Okay, x less than or equal to minus 1. So you should not take this value. You should not take minus 1, means take minus 2. If you take a minus 2, this is a minus 4. Take a minus 2 plus 4, then the graph will be like this, straight line you have to take. So therefore there is a gap here. Here gap is there. So you cannot by any means you cannot define the by, because here see the domain is a continuous, x less than minus 1, x greater than or equal to minus 1. It is a continuous domain. It is a continuous domain. So therefore you cannot define the by any means you cannot fill this gap. That's why it is a non-removable, and we call it as a jump type, the function. So the curve comes like this, up to here it came, up to here it came, again it jumped here, and it is continuous like this. So that's why this is called jump type of discontinuity. Okay, now, so which we cannot removable. Now let us take a infinite type of this means what? So f of x is equal to 1 by x graph, we know that. F of x is equal to 1 by x graph, we know that. So this will be like this. So this will be like this. Okay. So the graph will be like this. Okay, now, so at x is equal to 0, the function is discontinuous. At x is equal to 0, the function is discontinuous. So by at any means you cannot connect those two graphs, these two curves. This is a come to infinity, it goes on infinity, and it is goes on infinity, upper direction, it is going downward direction. So it is not at all possible to connect those two curves. Okay, now, so from if you want to connect, so it is tends to infinity, it is also tends to infinity. Further also you cannot connect those two branches, also you cannot connect. So these two branches you cannot connect. That's why this also non-removable discontinuity function. So these are the two types, these are the three types, and the oscillatory type of discontinuity also there. So if you see the f of x is equal to sine of pi by x graph, sine of pi by x graph. This is called third one, non-removable. So sorry, non-removable. So if you see this graph also minus 1 to 1. So this is also 1 minus 1. It is like this oscillates between that's way. So it cannot take these values. That is oscillatory function is also there, somewhat advanced point that is. So these are the main, these two types are there. So these are the very, very important points. So I hope that today you understand this total theoretical part, and that tomorrow's class I will explain the problems based on this theoretical part. Okay, I hope that you enjoyed today's class.